Students of 10th standard. Nowadays we are revising the textbook evaluation of periodic classification of elements. So far we have discussed objectives and short answers. Now we are going to discuss about the long answer. There are few long answer questions in the textbook evaluation. When you move to page number 122, Roman letter 7, state the reason for addition of caustic alkali to bauxite ore during purification of bauxite. State the reason for addition of caustic alkali to bauxite ore during purification of bauxite. This is first one. In the same question, second substitution, along with the cryolite and alumina, another substance is added to electrolyte mixture. Name the substance and give one reason for the addition. So first one, see, state the reason for the addition of caustic alkali. Here we move to page number 1. It is given that is that bauxite ore is actually insoluble. Bauxite ore is insoluble in normal solvent, so it is added with the caustic alkali. Page number here it is given, see page number 115. Conversion of bauxite into alumina by S process. In this process, bauxite ore is finely ground and heated under pressure with a solution of concentrated caustic soda solution at 150 degrees Celsius to obtain sodium metaluminate. So why is this caustic soda is added? At normal condition, bauxite will not dissolve in normal solvent. Therefore, addition of caustic alkali to bauxite plays an important role while extraction of aluminium. So, caustic soda is added to dissolve the ore. Then, caustic alkali dissolves bauxite, forming soluble sodium metaluminate. Here the sodium metaluminate is formed, and which is going to be soluble because of the addition of caustic soda, and the impurities remain insoluble and precipitate as red mud. So that bauxite is going to be give soluble metaluminate. The impurities are going to be insoluble because of the addition of caustic soda. Actually, you have tried one reaction, one chemical reaction. Here it is not given, only one reaction is given. For the formation of sodium metaluminate also you have tried one equation. That is, first you have tried the formula for bauxite ore, Al2O3 2H2O plus 2NaOH. 2NaOH gives sodium metaluminate. The formula for sodium metaluminate is 2NaAlO2. 2Na sodium, Al aluminium, O2. That is sodium metaluminate plus 3H2O plus 3 moles of water. So here, this is the equation for the sodium metaluminate by the addition of caustic soda. Also, the same question, one more subdivision. Along with the cryolite and alumina, another substance is added to the electrolyte mixture. Name the substance and give one reason for the addition. Here, along with the cryolite and alumina, another substance is added to the electrolyte mixture, that is fluorspar. Here it is given, see in the last para. pure alumina plus molten cryolite plus fluorspar. What is the reason for the addition of fluorspar? It is given in the bracket. Fluorspar lowers the fusion temperature of electrolyte. Fluorspar lowers the fusion temperature of electrolyte. For that purpose, it is added. So you have tried these two things for the first detail. Then next question, and this second question is that is the electronic configuration of metal A is 2, 8, 8, 18, 1. Electronic configuration of metal A is 2, 8, 18, 1. The metal A, when exposed to air and moisture, forms B, a green layered compound. A with concentrated sulfuric acid form C and D along with water. D is a gaseous compound. Find A, B, C, D. So here you can understand simply that is the electronic configuration of metal A is 2, 8, 18, 1, and it's also given that metal exposed to moisture, a green layer is formed. Green layer normally formed when copper is reacted. So what is the metal A with the electronic configuration? You can take to page number the copper, that is, see here it is given copper. The electronic configuration of copper is 2, 8, 18, 1. Electronic configuration of copper is 2, 18, 8, 18, 1. Also it is given in the previous pages. You can take here it is not given. Move to page number here you can see here the chemical properties. So A is copper with electronic configuration 2, 8, 18, 1. And the same question gives when metal A react with the moisture, a green layered compound is formed. That is here given. See, moisture, action of air and moisture. First reaction, copper gets covered with the green layer of basic copper carbonate in the presence of carbon dioxide and moisture. So copper react with the moisture and also with the carbon dioxide to form basic copper carbonate. This basic copper carbonate is going to give a green color layer on the surface of the or foldings of the copper vessel. So the equation is 2 moles of copper plus oxygen plus carbon dioxide plus water gives copper carbonate with the copper hydroxide. This is basic copper carbonate, copper hydroxide. So this is the reaction for the formation of a basic copper carbonate with a green color layer. This is a type of corrosion take place in the copper vessel. Then also that copper A react with the concentrated sulfuric acid to give copper sulfate. That is, you have to move to the reaction here in the first column, last one, with the dilute nitric acid. In that last reaction, copper plus 2H2SO4 sulfuric acid gives copper sulfate plus sulfur dioxide gas plus water. So copper also react with the sulfuric acid. Copper also react with the sulfuric acid, gives a copper sulfate salt, and sulfur dioxide gas is evolved along with the water. So what are the product formed? That is copper sulfate and sulfur dioxide. That is copper sulfate is C, sulfur dioxide is D. So according to the question pattern, see what is A? A is copper, B is copper carbonate, basic copper carbonate, formula CuCO3, CuOH twice, C copper sulfate, that is CuSO4, and D sulfur dioxide, D sulfur dioxide, sulfur dioxide. So these reactions also the explanation and the outright. What is A, B, C, D? A is copper, B is copper carbonate, C is copper sulfate, and D is sulfur dioxide. All this you have to write for this answer. Then one more question is given, that is what is smelting? What is smelting? Is a big answer. Page number, explain smelting process. Explain smelting process is given in page number 118. 118. See here it is take place in the extraction of iron. Extraction of iron. So here in smelting in blast furnace, the charge consisting of roasted ore, coke, and limestone in the ratio of 8:4:1, which is smelted in blast furnace by introducing it through the cup and cone arrangement at the top. There are three important regions in the furnace. So smelting takes place in the blast furnace and the addition of charge. Charge means roasted ore, which consists of coke and limestone. Ore, coke, limestone, the ratio of 8:4:1. This is called as charge. This is added through cup and cone arrangement, which is given at the top of the blast furnace. Then there are three important regions in the furnace. First one, a lower region, that is called compression zone. So in this compression zone, temperature is 1500 degrees Celsius. This is the bottom of the blast furnace. Bottom, the temperature is more. So what happens in this region, the coke burn with oxygen and carbon dioxide is formed. Carbon dioxide is formed. When the charge comes in contact with the hot blast air, carbon burn in presence of oxygen at 1500 degrees Celsius. Carbon dioxide gas along with the excess of heat is liberated. This is a exothermic reaction because heat is given out. Then the middle zone, that is at the middle uh, portion of the blast furnace. This is also called fusion zone. The temperature is 1000 degrees Celsius. In this region, carbon dioxide is reduced to carbon monoxide. Carbon monoxide. Yes, the reduction takes place. Carbon dioxide, that is the removal of oxygen, reduction. So carbon dioxide plus carbon at 1000 degrees Celsius, carbon monoxide. Here heat is uh, taken. Heat is taken for the uh, reduction reaction. Heat is taken. So that is endothermic reaction, which gives out heat is exothermic. Reaction which absorb the heat is endothermic. The limestone decomposes to calcium oxide and carbon dioxide. The calcium carbonate, because of heat, decomposed into calcium oxide and carbon dioxide. This is also endothermic reaction. So these two reactions are endothermic due to heat is absorbed. Calcium oxide combined with the silica and form calcium silicate, which is removed as a calcium slag through this slag outlet. Then next region, the upper region, that is reduction zone. That is reduction zone. The temperature is 400 degrees Celsius. In this region, carbon monoxide reduces to ferric oxide to form a fully pure spongy iron. So in this region only, iron is obtained because of reduction. Reduction. This iron oxide is reduced in presence of carbon monoxide at 400 degrees Celsius, iron and carbon dioxide. So, a pure spongy iron is obtained. The molten iron is collected at the bottom of the furnace after removing slag. This iron is called pig iron, and it is remelted and cast into different molds. And after that, it is called cast iron. When it is allowed in the mold to get different uh, shape, it is called cast iron. So there are three regions in the smelting process. One is lower region, which is uh, take place at the bottom of the blast furnace at 1500 degrees Celsius. It is a that is here the carbon combined with oxygen, carbon dioxide, and enormous heat is given out. So exothermic. Middle region, fusion zone, temperature is 1000 degree, and here carbon dioxide is reduced to carbon monoxide, calcium carbonate decomposed to calcium oxide and carbon dioxide, and calcium oxide with SiO2, calcium silicate, slag is formed. Here heat is absorbed, so it is endothermic reaction. And in the last, that is upper region reduction zone, the dioxide of iron is reduced in presence of carbon monoxide at 400 degrees Celsius. So a spongy iron is formed, and it is remelted and allowed in the molds, and cast iron is obtained. Cast iron is obtained. So these are the three uh, steps and reaction take place in the smelting in blast furnace. So go through all these three details and prepare well, and remaining we will see in the next class. Thank you. God bless you.